of right now. This is being recorded for your YouTube channel. And I'm going to switch over. I'm going to go ahead and share my screen. And let's do that. Don't think we need that. Do that and do this. All right, so okay, so we got the three main structures here. We did sequential right off the bat, and we did decision, selection, and finally we get to repetition or iteration, the nerd term for it. All right. In Java, there's three basic, I would call them, keywords to do repetition. The first one is a do loop. The second one is a while loop. Last one is a for loop. Okay. All of our loops have four parts. So the first part is to initialize. Initialize. Let's put it that way. And then test. And then process. And this is the one where people get in trouble, is incrementation or increment. Okay? Because if you don't increment, you get a problem with what's called an infinite loop. In other words, there's no way to stop it from looping. The user can't stop it. Okay, they start the program and it never ends. That's bad. Okay, so that has to do with incrementing. So you have to be able to change the condition that we're testing for somewhere in the loop, or it doesn't end. Okay, it doesn't end. All right, so a do loop is what we call a post-test loop. In other words, it will always run at least one time. No way to stop it. A while loop is a pre-test loop. It may never run at all. Depending on condition. And a for loop is more of a, we're just going to call it, it does do, what would I call it? It is a pre-test, but it's more of a counting loop. And that means used if I know up front how many times I want it to run. Okay, the other two can run indefinitely, depending on the incrementation. In other words, the do loop, we're going to use it to run our programs. And our programs will run forever, as long as the users keep saying, yes, I want to continue. Yes, I want to continue. Yes, I want to continue. So that's indeterminate. I don't know that up front. Same thing with a pre-test loop. If somebody types in the wrong thing, we just keep beating them up. Beat them up, beat them up, beat them up until they put something in that's valid. Okay. Yeah. So those are the main guidelines of how things go. Okay, let's see, what else do you need to know about loops? Do, while, and for. For parts, initialize, test, process, increment. Infinite loops are bad. So those are the basics. I mean, literally, in that, there's your that's loops in a nutshell. Doug's loops in 5 minutes. But to conquer them, to know how they use them in Java takes a while. Okay, especially because we're going to have a lot of conditions. The conditions have to change. So going back to our decisions, we had our relational operators, the less than, more than, those types of things. And then, of course, we had our logical operators, not, and, or, and XOR, that also come into play when we work with repetition. What else I got in this? Let's see, did that. So, of course, we're going to put our whole program inside one of these loops to start out. And then we'll break it into different parts, and it'll be so cool. Okay, let's jump over to, I thought I had this open already. Always something, BB. I had this open not 10 seconds ago. All right, so you guys are 1928, I believe. Let's run down here. This is lesson 6. Okay, there's some videos I popped in here. These are not mine, but the guy explains some stuff, not bad. Just remember that he'll use things like I for a variable name, and you guys are going to use whole words like index or count or number, something like that. You'll get points removed anytime you use a single letter variable, even though your book doesn't. And a lot of times people that show you how to program try to do that. Okay, so from now on, all programs must be able to run multiple times. If they don't, you lose the whole point. Okay. I gave you an example of how that works. Okay, right here, there's a zip. Basically, it just, here, let me open it up here real quick. So I'm in Notepad right now. Okay, you guys seeing this?
Yeah.
Yes.
Yep.
Okay, so this is a do loop. So this, what kind of loop? Is this a post or a pre?
Post.
Yeah, this program will always run at least one time. And you can see that. I'm setting up my scanner here. I'm setting up a variable called play again. Okay, so I go into the loop here and it does stuff. Even before it's tested, the test doesn't come in until way down here. So I have my initialization, okay? Then I have some type of process here. Then I have my incrementation, and then I have my test, okay? So you can see here, I've got a char. A char means it's just one character. Notice the single quotes around the end. I got a do here. I print something out. And then I ask them, do you wish to continue, Y or N? Okay. And then the string temp is equal to, I can fix that so we don't need that. But so then here I take the temp, change it into an uppercase letter, or actually I do it this way. I get whatever they type in, get the first character, because again, it's read from right to left. Then I change it to uppercase. So they type in a small letter Y, or they type in yak or yellow. It takes the Y off the front of it. Then it turns to an uppercase Y, and then that's saved as play again. So then when it comes down here, it says while uppercase Y is equal to uppercase Y, keep looping. Any other character they type in besides a word starting with an uppercase Y will cause this program to stop working. Okay. So once again, it's a do loop, post test, initialization up here, some type of process in here, incrementation in here, and then a test out here. Notice that play again has to be outside the loop. The loop only runs from here to here. So when I test for while, it's outside the loop. The scope, if I put play again inside the loop, I can't stop the loop, because play again could not be seen on the outside. Okay. So it has to be outside the loop so I can see it down here. I can increment it inside the loop because the scope is anywhere inside the main. Okay. If I put it in here, the scope of it is only from this point here to this point here. So I wouldn't be able to see play it again if in fact I put it inside my loop. And that's an important feature here. So I gave you this code. It's right in the, come on, stop. It's right up here at the top. First thing, the first program here, okay, is changing a binary number into a decimal number. And I'm going to give you an example of that. I give it to you here, but let's go over it so everybody kind of, if you've never done this before. I'll just come down here. Okay, so we got a base 10 number 247. Base 10. And I want to change that into a binary number, whatever it's going to be. Means it's base 2, right? Why? Because that's the way computers work. They use binary, they don't use decimal. So how it starts out is I have 247 here, 247, and I'm going to divide that by 2. Okay. And 247 divided by 2 is equal to 123, right? With a remainder of 1. So now I got 123 divided by 2, and that gives me 61, the remainder of 1. Then I get 61 divided by 2 gives me 30 with the remainder of 1. 30 divided by 2 gives me 15 with a remainder of 0. 15 divided by 2 gives me 7 with the remainder of 1. 7 divided by 2, whoops, 7 space that 2. Oh, I don't want to do that. converting it. It saw 7-2 and it wants to convert it into a date. It didn't do the other ones because of they're impossible. So 7 divided by 2 is what again? 3. The remainder of 1. I was never a math wizard. 3 divided by 2. Oh. Okay. 3 divided by 2 then is equal to 1. With the remainder of 1. And then 1 divided by 2 is 0 with a remainder of 1. Oops. Okay. So now you're saying, well, what does that have to do with our binary number? Well, if you start at the bottom and read these numbers backwards, okay, 247 is equal to 1, 1, 1, 1, 0, 1, 1, 1. That's what it's equal to. So now to write this program, what you're going to do is concatenate onto the front of what you have from before. So you're going to divide the number by 2 in a loop, and it will have a remainder. And you can always get the remainder by using a what? A modulus, okay. I heard somebody say that, not really, but so you use a percent sign, right? And against the number, whatever the number is they want to convert, and it'll leave that remainder every time. And you put that in a loop, and then you take that, whatever it's going to be, you can have it as a string, and you can concatenate on the end of it or on the front of it by saying whatever you might call it remainder plus num. Because you want it to go on the front end. Okay. If you put it on the back end, you're going to get this number backwards. So you would get 1110, 1111, which definitely isn't 247. When you go to test it, here's an easy test. If you put in the number 4 in decimal, it should come out to be what? Anybody know? What is 4 as a binary number?
Should be 100.
Well, it's 100. It's not 100.
Yeah, 100. Sorry.
Yeah, it should be 100. If you get 001, you have it exactly backwards. You need to change the order that you have here. Okay. So that's that homework assignment explained anyway. So that's that one. The next one is heads and tails, and this one's not rocket science. In this one, I want you to roll or flip a coin 1,000,000 times. So your loop is going to run 1,000,000 times. Now, here's the clue. Don't put out every roll. Do not print them out. You'll have 1,000,000 lines of printing. And it will take your computer a while to do it. You can try it if you want, but it's not what I'm looking for. what you're going to do is run it, have a random number, right? You're going to have something like, let's see here. Int. You could actually use a byte, but I'll just say toss is equal to, let's say I have something called my random dot next int. And then I would say 2. Okay. And then all you'd have is an if statement saying if toss is equal to 0, then you would want to go ahead and add. You'd have heads plus equals 1. Then you could have below that, you'd have your else, and then that one would be tails plus equals 1. Like that. And after it runs a million times, you're just going to print out who had heads, or how many heads you had and how many tails you had. Now, what you need to do is get that inside your loop, though. I don't want it where if I run it 2 times, it comes up with 2 million. My count, you have to be able to clean out the heads and the tails each time you run it. Okay. So you want them to reinitialize inside your do, but not inside the, well, it don't matter, even if it's inside the loop. Your heads and tails should not be inside, though, of the loop, because then it'll never get past 1. So your loop would be here, start here. Outside of that, you would have your declaration for your heads and the tails. Your toss can be inside the loop. Your toss could be inside the loop. Now, it says something about Rosencrantz and Guildenstern. That's just, I mean, I was just feeling Rosencrantz and Guildenstern have to do with Macbeth. Okay, so if you come over here and type in Rosencrantz, there you go. Are Dead by Tom Shepard. Okay. And so Hamlet, I always call it Macbeth. If you don't know the story, Hamlet finds out that his uncle and his mother killed his father, the king. Okay. So then he sees the ghost of his father. He's going to take revenge on his mother and the king. But Claudius and his mom are going to send him to England to get him killed. Okay. And it has to do, so they're supposed to spy on him and then take him to be killed. So the king gives them a letter, though, to, I think it's the King of England or something to that effect. And inside the letter, that sealed letter is, oh, go ahead and kill Hamlet, but also kill Rosencrantz and Guildenstern. So in the play, they're flipping a coin, and the coin always comes up heads. And it has to do with, it's the symbol that their fate is sealed, you know? Okay. So it's interesting. I've seen it done a few times in at different theaters, and it's been a movie. The movie I didn't think was very good. So Okay, so that's that one. So if you add something to make it kind of Rosencrantz and Guildenstern-y, I give you a little extra credit, okay? Use your brain cells to do that. The one we're going to do together tonight will be the elementary math one, and I made it up. So it's we're going to get two numbers, and then the user is going to pick, and it's like a trainer, right, for elementary kids. For, well, nowadays, hell, it could be high school. But the only numbers we're going to use are 0 through 10, no negative numbers, no fractions or no decimals. So we're going to create this thing, and it's going to run multiple times. Once the numbers are generated, the student gets to pick if they want to do addition, subtraction, multiplication, or division. And then it'll keep track of what their score is. So any questions on the homework? Anybody still with me?
With you, no questions.
Okay.
No questions.
All right, so let's crank up the old NetBeans. Hang on a second, I need different coffee. All right, get some new coffee here. Okay, so file, new project, the infamous ANT. And we'll just call it Math Tutor. I gotta trade my coffee here. It's the time of the day I changed to iced decaf from caffeinated. I think I'm addicted to coffee. I think if you drink coffee from the time you wake up to the time you go to bed, you probably have a coffee problem. Acme Math Tutor. Okay, and then this will be mathtutor.java. And the date today, we're moving right along through this month. February 2021. Author. Purpose is a program to teach elementary math operations, addition, subtraction, multiplication. Oh, geez. Division, where numbers will be between 0 and 10. No decimal fractions are used. Again, so something like 3 goes into 10, we're not going to use. And I'll show you how we're going to fix that, though. Because we want them to be able to learn that, but we don't want to have any decimals available to them at this point. No negative numbers are allowed. And of course, division by 0 is illegal. You can divide into 0, but you cannot divide by 0. And what else do we want? I think that's pretty, oh, let's do this. How's that for a description? Lose that. Lose this. Both of those are for Java docs. I'm going to move my braces down. Indent this a little more just because I like to. Lose this here. Tab that over. And then I'm going to put my small divider in for now, again, just to keep in practice. So let's say void, oops. All right, save that because that's where we start. Okay, when I'm reading this, it's a division where numbers will, oh, let's make this randomly generated numbers will be between 0 and 10. So now that I know that, I know I need to import a Java utility called random. That's the first time 2 times a day I've gotten by without locking it up. And so now I lock it up. And I just don't understand why it always does that. Now it's going to change the name on me. Yep. I don't think I typed that fast, but. And of course, the student's going to type in an answer, so I also need the scanner. Got that. And we're going to drop down here. Ooh, not there. I don't want to drop down to. Inside my main. Okay, so first thing, let's see, what do I want to do? Let's do the do. So I'm going to make a variable, and I will call it, I can't use continue because that's a reserved word. So I think I'll just use keep going. So I am going to have a char called keep going. And I'm going to initialize it to a Y. Notice again, those are single quotes there. Okay. So here I'm initializing my loop. And then I can type do. And I put my braces underneath that. Okay, so now I'm inside the loop. Okay. And here, let's just put, some type of process. I know what I'll do. I'll put, what do I want to do? System.out.println. Hello. I hate when people do that. Hello, world. Okay, so that's my process. So let me I'm going to remove this, but just for now. Okay, so that's the second part of my loop. So now I need an incrementation. So here we're going to say system.out.print, and I'm going to say press Y to continue, all others quit. Looks like that. And here I'm going to change keep going is going to be equal to, okay, I need to get a scanner. So I'm going to go back up here and declare my scanner as user con. The type system in. Okay, so now I have that. So now I can get something. So I can say user con dot next. Okay. And to upper. And then I want to pick off the first character. So I'm going to say to char or at char. And the char I want is at 0. Okay. So now I got that. Oh, what happened here? Okay. Stop. It's char at 0, and I had it at char. There we go. And then outside the loop, right next to the brace, I'm going to put while keep going is equal to a Y, like that, uppercase Y. I'm going to save that. Run it. And you can see it says hello. If I type a small letter Y, it says hello again. If I type an uppercase Y, it says hello again. If I type yak, it says hello again. If I type stop yellow, it says hello again. If I type S, it quits. So anything but a word that starts with Y has it keep going. So if they type yes, if they type anything with a cat with any type of Y, it doesn't have to be uppercase because we fixed that. We change it on them. So now our program runs. So we had this, our actual incrementation is here. And then we have our test outside the loop. So there's all 4 parts of our loop. So our loop runs correctly. Okay. As we go, make sure you ask questions. Again, we're going to build it piece by piece as we go. So now I want to give us a banner of some type. And I'll just do this. And then I'll do this. Oops, it gave me a. I'll see how close I am here. sometimes it's not what you see is what you get, or what's called, you guys know the term WYSIWYG? WYSIWYG is short for what you see is what you get. And that's a big term in printing when you print to a printer. Back in the day, we didn't have that. But then a company called Adobe, which was a guy from Apple left and went out on his own up in Canada. And he opened a company called Adobe. And they were the first ones. They wrote a program so that when you printed something on a computer, what you saw on the computer is what you got from the printer. Okay. And they called it WYSIWYG. And it was interesting. Hey, I'm not too far off. I think if I take one space out in front of my Acme, I might be okay. Let's see how that works. Oh, and of course, I left it running. Beautiful. Beautiful, beautiful. But see, now you have to type N here to shut down the program, because you'll have 10 different programs running in the background. Okay. And at some point it'll say you won't get your run button back because you have programs running. You just go over to your output, and you can either, if it's running, you can click on this red button here. Like here, if I run this, I can click to stop it. I just need to type any letter but Y. Or I can come up here and just click stop. And that stops the program from running. All right, so that gives me that. I need to get some space here. So, all right. And so then we want to have system.out.print line or print. And let's do it this way. Capital A for addition. And then slash N. Whoops. Enter. And then subtraction slash N. And then multiplication. See, when I type slash N, and if I just hit enter, it starts the new line. Okay. I'm not typing that. It puts it in automatically for me. And then I put slash N and I hit enter. Moves me down one. So I got addition, subtraction, multiplication. Select operation A, S, M, or D. Okay, so now I'll see what it looks like. Okay, I forgot. Once I put in my selection in for the user, this will move to another line, so it's not a problem. But this is what it looks like right now. And I think that looks pretty good. You could move them over a little bit if you wanted to. We can take a look at that real quick and see if, in fact, we'd prefer just what we want it to look like. So you put a slash T in front of that first brace, or first parentheses, I should say, not brace. Okay. And let's see if that looks prettier, more professional anyway. Might move them over too far. Let's see how that, oh, I'm running again. You can Was the run down there also. Yes, stop that. And then my green comes back on. Let's see what it looks like. Oh, I kind of like that, right? Don't think about this part right here. But this looks pretty good. I could take the select and move it back. Take the T out of there. And then again, I got it running again. I should hit N every time and it would. See how that looks. Select, yeah. Yeah, I like that. It'll look kind of cool. Easy to read that way, right? All right, so I got there. So now we need to get their answer, okay? So we'll have something called char, how about char choice? Is equal to, can I do nothing? I don't think I can do nothing. We'll just put an X in there for now. There we go. All right, so chart choice, I have that there. And I have my scanner, so I can say choice. Oh, maybe I don't need that. Let's do it this way. If I declare it there, I should be able to get it there. So we'll just do it this way. User con is backspace dot, oops, dot next dot to upper dot char at 0 again. All right, and then we'll go ahead and see if that works. And I'm running again, close that, yes. Green light goes on. All right, so there you go. If I type the letter A, I get an uppercase A, and that's what I want. I hit N for no, and it stops. Or you could test them all. You can run this one. So if I type in an A, prints out an A. If I type a Y, brings my menu back up. I type an S, comes up. Do you want to run it again? Sure, why not? Type an M, I get my M, type a Y, type my D, and an N to get out of it, and the program shuts down. Okay, anybody's not running at this point.
Mine's running, but it's displaying two. Mine's running, but it's giving me an error at the end. Do you mind if I share my screen and show
Nope,
you what I mean?
hang on, let me hook you up here. Okay, we got you. Go ahead. All right. Whoops. Type in an N. Well, that works. Run it again. What's it? Oh, that's you doing that. Okay. Okay, so that works. I don't see an error. Meredith, where's your error? Except for the hello. Get rid of that hello up there. That system out print line hello. Dump that. I don't see the error. It's running fine.
Sorry, I should have rephrased myself. When it said when I was running the program, it it gives me like a lowercase. It prints two of the same character out.
No,
I'm not
one
sure if
is
that's
the
really
one.
called.
One is the one you're typing. Is it not?
Yes.
Yeah. So if you
Okay.
type an uppercase A, you'll get two uppercase A. All we're doing is printing it out.
Okay.
So if you
Sorry.
type an uppercase A, that's because you're also, let me see your thing here. Choice is equal to that. Chart choice, print choice. Yeah, why is it doing that?
See.
Why is it printing what you're typing? So I don't think mine did that, did it?
No, I don't think. No.
Two uppercase, chart 0, chart choice, system out print line choice. And then we're down here. That's that's fine. I don't see anything different about yours than mine. Go up to the, I don't know that this is going to do anything, but go up on the top menu and go to run and go down to clean build project and click on it. Clean build, up, 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 up,
Oh,
right. Click on it. Now run it. So is it printing a small letter A there, or what is it printing?
yeah, it's printing a small letter A. Yep.
Okay.
Small
I'm going to
letters.
stop. So stop sharing. I want to see if mine does the same thing.
Okay.
So if I run mine, does it do that? I don't know. So I type a small letter A there and hit enter. Whoops. Hello. Type a small letter A. Oh, yeah, it does. I'm just printing mine off to the side here.
Okay.
Okay. But wait, I'm only getting one. You're getting two.
Yeah.
So that's weird. Oh, hang on a second. Hang on. I'm not printing mine out right now. It's just printing what I'm typing. So if I put in a system out print line and then put in choice, I get the same thing you do.
Okay.
Yeah.
Okay.
Gee.
Okay. Thank you.
Yeah, if I run mine, when I type the letter A, I get a small letter A there, hit enter, and there's the uppercase A that I printed out.
Okay. Thank you.
So you're good. You're good. Working good. All right. So here's our dilemma. Only A, S, M, and D are allowed. Okay. That's all that's allowed. So we need to beat them up if they put in anything else. Right? So I'm going to say, see if I can get this right the first time. While choice is not equal to an A and choice is not equal to a S, an S, I don't know what it would be. And choice is not equal to a M, and choice is not equal to a D, we're going to say, let's see if I do that. If I put a do around that, first of all, I want to get rid of this up here. So if I put another do in here, yeah, let's do that. Okay, I'm going to move the declaration of the char outside my new loop here. So I'm going to put a loop in here. Another do. And I'm going to move all this inside the loop. And then I'll go ahead and indent that. So all this will be indented. 1, 2. And then outside this loop, I need my choice declared. So char choice is assigned a value X. Or no, what did I have? Choices user con. Yeah, that's fine. So then it comes here, and then delete, delete. Come on, you can come up there. Come on, you can do it. All right, and then I want a semicolon on the end of that. Okay, and then here I need a little statement that says if, and then I'm going to copy all these. Control C, pop them in that if statement, Control V. And I can just say system.out .println only A, S, M, or D are valid responses. Okay. So I got a little message to them. And let's try this now, because sometimes my logic isn't always kosher. I got this to here, this goes here. So again, I have to quit the program because I have it running. All right, and we run it. So if I type the letter A, that's fine, okay. If I type the letter X, it says select operation A, S, M, or D. Okay, wait, and then it says only A, S, M, and D are valid responses, and it pops up a new menu. I type S, and I get that. I type an N, and I can quit. But as long as if I don't type an A, S, M, or D, again, did you see that? If I type, an exclamation point, it says, nope, that's not right. How about the letter X? Nope, that's not right. T, nope, not right. Period, nope, not right. Type the letter A, boom, it goes to the continue. I can hit continue again. I can hit that, M, and then N, and I quit. So there we fixed that. So there's user friendliness, right? Okay, user friendliness. We got a menu. They have to pick one of these, or we just keep beating them up until they do. You with me?
Can you pause for like 1 second so I can just copy?
Yeah, it's a little going fast for me here.
Yeah, same.
Okay. We can wait. Kidding. So here again, we added this do in here because we wanted to check whether or not they're going to put something in. Whew. Sorry about that. And if you think about the logic here, when it says choice not equal to A, okay, so that is, if I type the letter X, well, X is not equal to A, so that's true. X is not equal to S, that's true. X is not equal to M, that's true. And X is not equal to D, so that's true. So I have 4 truths separated by ands, so the whole statement is true. And then so it prints out that A, S, and M and D are the only valid. Same thing down here is it keeps running until it sees an A, S, M, or a D. You guys done?
I have something that says illegal start to an expression, so I think I must have like a syntax problem, maybe.
Okay, did you put a semicolon like on the end of this?
No,
You shouldn't have one.
don't have one there.
Do you have one here?
Yes.
Okay. Do you have one here?
Yes.
Okay, go ahead and share then. Hang on.
Okay.
Do it.
Sorry, 1 second.
No, that's all right. See if your peers can pick it up. Ooh, yikes.
I know, I was trying to keep up and I got confused.
And okay, here, let's see. And choice, S and. Oops, you're missing your choice in the first line. For the M, over in
Okay.
number, you see it? Down, keep going down, right there, in front of the not equal to. Right there.
Oh,
Missing the word.
so I just didn't type, I missed that, and then I'm missing it here.
Yep.
Okay.
Ta-da!
Yay. Okay, should I try that?
Yeah, try it.
Okay, I didn't get an error, so that's good.
That's a good thing. Whoops, you
Sorry, I
typed
think my
A up
internet's
and-
a little slow
That's
here.
all right. So
All right, what should I try here?
just N is fine. There you go.
Okay. Thank you.
But you typed the letter A in your code up here instead of addition down below.
Oh, whoopsies.
Just take that out. There you go.
Okay.
You're
Thanks.
good. Yep.
All right. Thank you so
Anybody
much.
else? Okay, we're moving. We're moving. All right, so let's get us some numbers, okay? So we got to, did we create our randomizer? No, let's create a random up here. So random, user rand something. Do I want that? No, let's make it num rand is equal to a new random. And let's go down here. And then we'll say int num1 is equal to num rand point next int. And we said 0 through 10, right? So that'll just be an 11 there. And then guess what? Int num2 will be equal to a num rand next int of 11. And again, that gives us 0 through 10. It'll never generate an 11. Okay. All right. So now we'll do a switch, I think. Probably the easiest way to do it on choice, since we only have 4 choices. And then we will put our braces in, and case A will be, let's see what I want. Okay, so that, and then this time we're going to put them down below. So this will be a system out print. I'm going to use printf. Okay, so that's print formatted. And I'm going to use a %d because that's an integer plus %d, another integer, is equal to something. Okay, so then we will go here, and this will just be num1, and num2 will fill in those placeholders. Okay, semicolon. And now we need in our do here. Let's see, outside of this loop. Where do I want it? Let me look here. All right, I think it can go here. So we're going to have something called int computer answer. And I'm going to initialize it to -1 because in our program it can never be that. And then we'll initialize 1 for user answer as long as we're here. It's equal to -1. Okay, so now here, the answer for that problem is going to be computer answer will be equal to num1 plus num2, right? And then we can come down one, say case S. And it'll be very similar, except I said there's no negative numbers, right? So if num1 is less than num2, I need to do a switch. And by that, I don't mean this kind of switch. I mean, I need to switch those two numbers. And you do it like this. So in that case, num1 or temp, int temp will be assigned the number in num1. Then num1 will become num2. Then num2 will become temp. And that's how you do a switch. Switch to two numbers.
Can you explain that one more time?
Switch the two numbers around. Okay. So basically what I do is I take number 1 and save it. Then I take number 2 and write over number 1. So here I'm taking, let's say that it generates the numbers 1 and 2. So here I'm moving the 1 into temp to temp. Then I take the number 2 and write over num1. So now num1 is 2. Then I take temp, which is 1, and put it in num2. So now it's 2 minus 1 instead of 1 minus 2. So now I can just come up here and copy this. Control C, then pop it in here. Control V. Change this to a minus sign. Change this to a minus sign. So there's my case S. Goes there. We could indent this a little more if we wanted to. Kind of like that in a little more like that. Do the same thing to this one. Okay, so then we're on enter case. Ooh, went crazy. Case multiply is an easy one because it's the same as the addition one. We don't have to do anything to it. So I'm just going to come up here, copy this, Control C it, come down here, Control V it. I need to move this again. It's off by 1 or 2 or 3. There we go. Now they line up perfect. And I'm not going to put an asterisk here. Again, this is elementary school kids. I'm going to put an X for multiply. But this one here has to be an asterisk, right? Or a splat, as we call it in the geek world. So I'll give you a second to catch up here. Again, we're just beating this up a point at a time, one thing at a time we're taking care of. We got our inputs up here or our choice. Now we're dealing with processing, just printing out our question and getting the first answer for the computer answer.
Some reason why my integer number 1 equals random.
Where? Up above?
Yeah, yeah. I don't know why it's not letting me do num rand.next. It's just not letting me. So I don't know if I didn't like clarify something.
Did you put in your random thing here?
Yep, that's it. Thank you.
Okay. Oh, you don't have that?
No, I don't.
Oh, okay. It's almost like magic how I know this stuff, isn't it? Kidding. I've just been doing this a long time. And there's only certain things that would cause, certain problems. Once you get used to it, you go, oh, yeah, I can't do that because I haven't done this yet. The last one down here is our old friend division. So a couple things we need to do with it. First of all, in division, in algebra, we cannot have division by 0. So if num2, oops, I better put an if in, huh? If num2 is equal to 0, all we're going to do here is num2 will be assigned a value of 1. Okay? Easy way to get rid of that. All right. So now, I'm going to put in another temporary. So I'm going to say int temp is equal to num1 times num2. Okay. Then I'm going to say that the computer answer to this problem is going to be num1. And I'll show you why here in a second. Remember, I told you this prevents any fractional answers. Because what I'm going to put up now is my question here is this. Instead of having num1 and num2, I'm going to have system.out.print, printf, sorry. I'm going to have temp, whoops, let's say %d divided by %d is equal to something. And then I'm going to put here, instead of num1, this will be temp to fill in the first one, and num2 to fill in the second one. So I'll give you an example here. Let's say num1 is 5 and num2 is 3. Okay. If all I did is take 3 and divided it into 5, I'm going to have a fraction, right? 1.666, whatever. If, however, I multiply num1 times num2, okay, I get 15. And so if I take 15 and divide it by 5, I get 3, which is a whole number. So now I turned it into where the answer will always be a whole number. Okay, I think that's, so now let's go outside of this. Is our switch, where's our end of our switch here? Switch. I think it's right there. Yep. So let's go outside of that and we'll print out what we have as our answer now. Let's just see if we can get an answer. So this is computer answer is what we're going to print out. All right, so I'm going to run my program and I'll pick A. Whoa, what happened there? Oh, I forgot my brakes. Did you see? Look at that. I want to show you what it did. So it took 0 plus 3 is 3, or then it did 0 plus 3. It did 3 minus 0, 3 times 0, 3 divided by 1. And then the only answer I got was the 3 for the division. That's because I didn't put in any brakes. So we need to go back up, put our brakes in. So that it stops. We want it to stop after each one. That was kind of a cool example there. Okay. Again, I need to stop my program. Okay, now I can run it again. And I type in the letter A and I get 3 plus 0 equals 3. That works. About an S. 1 minus 0 equals 1. That seems to work. How about an M? 8 times 3 is 24. I think that's right. And if I do a division, I get 15 divided by 3 is equal to 5. So that works. I type an N and the program quits. All right.
Mine is crashing on the division one.
Okay. You want to share it with us?
Sure.
Hang on a minute. And I'll let your fellow students look at it first and tell you why it might be. Yikes.
Needs to be printf.
Oh,
Ta-da! Run it. There you go. Type it in or whatever. All right, stop sharing.
thank you.
Okay, so now we got that. So now we don't want to print that out anymore because then the student would have that as their information.
Actually, I'm having a problem with my division. It's doing really big numbers.
All right, so let's see what you got, buddy. Oh, I'm sharing. Hang on. Okay, go ahead now. All right, you're getting really big numbers. Times temp is there. Okay. Divided by. In your print off, do me a favor, just clean it up. Put a space after the D
Mm-hmm. Oh,
and one before that. Yep. And then an equal sign after the D, the second D. Nope, nope, nope. After the second D.
am I?
One to your left. Go one to your left.
Mhm.
Nope, not there. The second D.
Is this?
Right there. Space equal sign. Space equal sign. Space equal sign. Okay. So now, why are you getting 101? Oh, let's go back up to the top or right there. Stop. Okay. So you could get a number up to 100, right? Because if it generated 10 and 10, maybe is it? Let's see.
Also, my integer user answer was spelt wrong, so maybe that had something to play because it wasn't.
No, that wouldn't. We haven't used that yet.
Oh.
Is our numbers off by one because I put a -1 there? It shouldn't. It should replace the whole thing. Run it. Let me see this down. Let me see your output again. We can't see it. Divided by 3 is 3.
Yeah, that looks better.
Yeah, I don't know why it was doing that. But you could get up to 100. You know that, right?
Mm-hmm. Mm-hmm.
Okay.
11.
Yeah, so it'll go up to 10. It generates 0 through 10
Okay.
is the only numbers it can generate.
Okay.
It'll never generate an 11. All right. So now we're ready to get some data from the user. So we're going to do this. We're going to say system dot out dot print. Enter your answer. Something to that effect. Okay. And again, I like my answer off to the right. So that's why I don't use a print line here. Another loop. Okay. This one is your how you're going to prevent them from crashing your system. And it's a while loop. So it may never run at all, depending on what they type in. And it's going to be not, what did I call it? User con? What did I call the user thing today? User con, yep. So not user con dot has next int, like that. And then we're going to come down here. And what that means is if they don't type a integer, it's going to go into the loop. And so we're going to tell them system out dot print line. That is not an integer answer. And then we'll say system.out.print line or print, enter your, or re-enter answer. Okay. And then I need to clear the buffer out. So we're going to put usercon.next like that. And then outside of the loop is where we're actually going to save their answer. So we're going to say user answer is equal to usercon.nextInt. So this right here, this whole section here is to protect you from them typing a letter and trying to put it into an integer, which would crash your system. Due to a incorrect data error. Okay, so we got that. So let's try it. All right, so I put in A. It says enter your answer, right? So if they type in the letter X, for example, it says that's not an integer answer, re-enter your answer. I say B, nope, not that one. If I type in 6, however, it works. All right, I don't like where my enter your answer is. I mean, it's not bad. Where was that at? We should probably go ahead and put in each one of our questions, let's put a /n. Or you know what? We can fix that with one spot. Let's put it right here. Just put a /n before, and that'll move that down a line for us. So that when we run it, and I type the letter A, there you go, and it says enter your answer there. And once again, if I try to put in anything other than an integer, like if I try to put in 2.2, it says nope, not an integer. If I put in 4, boom, I'm out. Okay, so that keeps it from crashing. All right, so now we got that part done. I'll give you a second to copy that.
Mine crashed.
Yours crashed.
Yeah, I'm kind of confused. I have the usercon because it isn't a doesn't equal usercon has an dot yet has next.
Yeah, it says while not. There's an exclamation point here.
Wow, yeah.
Usercon dot has next int, 2 parentheses. Hang on one second. I got my daughter has a problem here apparently. My daughter's car went kaput this morning, and she's just telling me her husband fixed it. So, all right, let's take a look, see what you got going.
Okay. I might be missing
All right, so you got a scanner problem, him input mismatch.
am I missing something that's
Let me look. Enter your answer, blah, blah, while dot usercon dot has next int. You're missing the int and the has next. There you go. Now run it. Ooh, endless loop, endless loop.
Right.
Okay, stop. To crash, stop that. Just hit the stop button off to the left there. The red dot over. Nope, not up there. Down by your output.
I think I just can't. I just closed it.
Okay, here's the problem. You didn't clear your buffer. So after re-enter your answer, no, just hit N.
Where? Here?
Right. Yeah, your program's still running though. See the red mark right across from your Math Tutor program where you're at down in the bottom. Off to the left, down here, hit that. There you go. Okay, so now go back up to your program and in the has next loop, after re-enter your answer, nope, in the has next loop.
Oh yes.
Okay, yeah, down two lines in the end of line 97. Go to the end of line 97. Okay, hit enter. Type user con dot next parentheses and then a semicolon. Now run it. Okay, type A or something. Yeah, there you go. There you go. Now type 50 or 4 or whatever. There you go. Type N to quit. All fixed.
Thank you. Thank you. Thank you.
Okay, let me back in. Okay, so we're back. So now we got that part done. So now we need to what? Check our answer. Oh, stop it. We don't need that anymore. Oh, yeah, I do. I'm missing the colon there. So now what are we going to do? We're going to say if user answer is equal to computer. Whoops, you got to be able to spell answer, Doug. It's equal to computer answer. We'll give them a nice little message that says something like system out print line. Good job. You're getting the hang of math. And then what I'm going to do here is this, and it's going to scream at me for a minute. I'm going to say correct plus equals 1. And it's going to say I haven't defined correct yet. Okay. So leave that for a second. Type that in, will you? And we're going to run all the way back up to the top. So way up here, underneath this char is, or well, even above that maybe, we couldn't even do. So we're going to do two things here. We're going to say correct, int correct is equal to 0. And then we're going to say int question count, something like that, is equal to 0. Inside the first do right here above char choice, we're going to put question count plus equals 1. Okay. Then down here, we've got correct. So now that's right. So now we can just say else system.out.println. Something like that. And I could have used the printf here too if I wanted to. All right, so we got that. And okay, what did I do yesterday that blew this thing up? I think what we're going to need to do here is let's make question count. Let's make it a double. And I'll show you because I want to calculate a percent with it later on. So this is, and so we'll say question count plus equals 1.0 here. And then we're going to come all the way outside of our right here when we exit the program for the day. After they've quit, they don't want to play anymore, we're going to say system.out.printf and put you got blank D questions correct out of percent 0.0 F for that's, I think that's good, just like that, /n. And then we'll do a double grade is equal to, oops, I forgot to put in the number, so this would be comma, this would be correct. And this would be, would I make a question number, or what was it? Question count. So that'll be that one. So then this will be correct divided by question count times 100. And then system.out.printf your grade is, it'll be we'll make it a percent 0.2F /n, and this will be grade. Oh, come on. Shift that. And let's see, let me run mine and see, I'll come back to it. We'll see if it works. Okay, so I'll do an addition and put 15 in. says, good job, you're getting the hang of math. We'll do another one. We'll do a subtraction. 1 minus 0 is 1. Good job. We'll do another one. Let's do a division. 9 divided by 1. I'm going to make an error here. I'll put 8. And it'll say, uh-oh, study more. And then I'm going to hit N to quit. And it says you got 2 questions correct out of 3. Your grade is 66.67, which is correct, right? 2 out of 3, 66%. So it looks like it's running, guys. So go ahead and get that part done. Told you these programs are going to get longer as we go. The honeymoon is over. Beautiful day out, I'll tell you. I'm hoping winter is over. Personally, I'm not a big winter fan. Any questions at this point?
Can you scroll up and show me the case M? Every time I press M, it just says enter your answer. It doesn't have a problem for me.
Let's see right here. So everybody good?
Mine crashed again. It says something as a missing format argument exception.
Yep.
For PD.
So down here somewhere, is it at the end when you try to get out that
Yeah,
it does it?
when I say no, it says yeah. it
Okay.
crashed.
So you got something wrong in here. This should be %.0f
Mhm.
is one of my guesses.
Mhm.
Do you have an F in front of this? Print F.
Yeah, I do.
Okay, let me see it then.
Mhm.
And we'll have your fellow students tell you what is your current problem. You haven't filled in what these are. What
Isn't
is
it-
your %D? In the line above that, you have to have after your /n.
Oh, yeah, sorry.
So it's the number, so correct. Whoops, yep, and then comma. And then QUEST, capital, there you go.
Okay, thank you.
And that should fix it.
I'm getting error too. Well, not an error, but it's just not working right.
Okay, let's see it.
I don't know how to share my screen.
Big green button.
Oh, okay. Can you see it?
Yep.
Oh, okay. It's not
Okay.
working.
What is it working?
So I got the
9
answer
plus
right.
3 is 13. Study more. The correct answer was, my talking Doug is right. Okay, there we go. Was -1. Okay. So why do you, let's see, scroll up to your addition problem.
Okay.
Well, you don't have anything in there for an answer. How about you put right there, yep, hit enter. Computer answer, COMPT answer is equal to num1 plus num2. Okay, run it now.
Okay.
All right, let me out. All right, so that just leaves us with, okay, so we have that. And so that leaves us with our cute little I'm going to put a /n in, move it down. Something like that. And then outside here somewhere, after everything else, let's just make it a little programmer friendly by just putting in no code follows. And then I save it, and then I run it by a few times. Okay, so let's just go to right to a D. And so I get 4 there. And then I'll do a Y again. Now I'll test my thing here and hit X. And it says only A, S, M, and D are valid. Brings up a new menu. I'll try D again. And 40 divided by 8. I'll type in the letter A. It says, well, that's not an integer. So I'll type in a 5 this time. It says, good job. I'll hit no. And it prints out that I got 2 questions out of 2 questions correct. And my grade is 100. So that's correct. I want to put an extra line in front of you got 2 questions out of 2 questions. So I'm going to come back up here and put a /n in front of this to give me a divider between where I answered the question above, right? So just a /n there. And I'm done. I save it and I put it in my portfolio. And I got you in here a minute early. Okay.
Real quick before we leave, could you scroll? Would you mind scrolling back up to the top where the correct and the quest CT
We're going to
variables
go
are?
right. Oops, I'm on top of my, scrolling on top of my, geez. Right here. Here's where I added the 1 for question count. And that had to be a double to prevent us from doing integer math, integer division when we calculated the percent. This is one way to do it. If I make that a double, then I'm dividing a double into an integer, so it'll become a double. If I don't, I'm going to get 0 every time.
Thank you.
Can you go to case S?
Case S, yep.
All right, hold on a second. All right, thanks.
You're welcome. Anybody else? All right, I'm going to stop sharing this. I'm going to stop recording.